Assalamualaikum. So for this chapter, introduction to three-phase circuit. Okay, so before this, we have deal with a single phase circuit where we have a generator connected to a single wire connected to a load. So the load it consists of a resistor, inductor, and capacitor. So before we continue to this chapter, let me introduce you what we will learn throughout this chapter. Okay, so basically for this chapter, we just cover on a balanced three-phase circuit. Okay, so the first things that we will introduce you is a phase sequence, and then we continue to a balanced YY circuit, and then balance delta delta circuit, and then balance delta Y circuit and balance Y delta circuit. Then we also cover on a power analysis in a three-phase circuit. Okay, let me explain you about a single phase system. So based on this figure, we have figure A and figure B. Okay, figure A depicts a single phase two-wire system. Okay, we have two-wire type where VP, where VP is the RMS magnitude of the source voltage and angle is the phase. So what is more common in practice is a single phase three-wire system is shown in figure B. So in figure B, it contains two identical sources, okay, which is equal in magnitude, okay, VP equal with magnitude, and the same phase. Okay, connected to two loads. Okay, connected to loads, we have ZL1 and ZL2. Okay, by two outer wires and the neutral. So we have wires A. Okay, connected wires A. Okay, then connected wire B with the neutral wire. For example, the normal household system is a single-phase three-wire system because the terminal voltage have the same magnitude and the same phase. Okay, such a system allows the connection of both 120 volt and 240 volt appliance. For a two-phase system, circuits or system in which the AC source operates at the same frequency but different phase are known as polyphase. Polyphase. Okay, so in this figure, it shows a two-phase three-wire system. Okay, when we have the magnitude is the same but with different angle. A two-phase system is produced by a generator, consists of two coils placed perpendicular to each other so that the voltage generated by one lags the other by 90 degrees. Okay, for a three-phase system, the three-phase system is produced by a generator, consists of three sources or three coils, okay, having the same amplitude and frequency but out of phase with each other by 120 degree. Okay, you see that we have three lines, line A, line B, line C, and one neutral lines. Okay, we have three input source. Okay, so all these source have the same magnitude, okay, the same frequency but different angles. Okay, let's say the line A is 0 degree, okay, line B is minus 120 degree, and line C is plus 120 degree. So all these wire have out of phase with 120 degree. Since the three-phase system is by far the most prevalent and most economical polyphase system, so we will discuss in this chapter mainly on a three-phase system. Three-phase systems are important for at least of these three reasons. Okay. First, nearly all electric power is generated and distributed in three-phase. Okay, let's say the operating frequency is about 60 hertz. Okay, or somewhere or 50 hertz. Okay, in this part of the world. Okay, so when two-phase or one-phase inputs are required, they are taken from the three-phase system rather than generated independently. So even when more than three phases are needed, okay, such as in aluminum industry, where 48 phases are required for melting purposes, so they can provide by manipulating the three-phase supply. Okay, the second things, the importance of a three-phase system is the instantaneous power in a three-phase system can be a constant, okay, not pulsating, okay, and this results in uniform power transmission and less vibration of a three-phase machine. Okay, the third one is for the same amount of power, the three-phase system is more economical than the single phase. So the amount of wire required for a three-phase system is less than that required for an equivalent single-phase system. A balanced three-phase voltage are often produced with a three-phase AC generator, or sometimes we call as an alternator. Okay, so this is a cross-sectional view for a AC generator, three-phase AC generator. So this generator basically consists of a rotating magnet. So you can see this one is a rotating magnet. Okay, we call it as a rotor. Surrounded by a stationary winding. Okay, this is a stationary winding. Okay, we call it as a stator. Okay, then we have three separate windings. Okay, three separate windings or coil. Okay, with terminals A to A, B to B, and C to C. Okay, physically placed 120 degrees apart from around the stator. Okay, this rotor will rotate. Okay, this rotor will rotate, and when the rotor rotates, the magnetic field will induce a voltage, same magnitude, but out of phase of 120 degree. Okay, since each coil can be regarded as a single phase generator by itself, the three-phase generator can supply power to both single phase and three-phase loads. Okay, so before I explain about the balanced three-phase voltage, okay, let us consider with this circuit. Okay, let's say we have a voltage source, okay, three voltage source. Okay, so the first voltage we call as VAN, okay, connected to line A. Okay, the second one we call as VBN, connected to line B. And the third one is VCN, connected to line C. Okay, so the point is this one is neutral line. Okay, we have neutral line. And that's why we call as this voltage as VAN, and voltage between line A and N. So VAN, but voltage between line B and N. Okay, that's why we call as VBN. And voltage between C and N. Okay, so we call as VCN. Okay, the voltage VAN, VBN, and VCN are respectively between lines A, B, and C, and with the neutral line. Okay, and this voltage VAN, VBN, and VCN we call as a phase voltage. Okay, so if the voltage source have the same amplitude and frequency, and with out of phase each other by 120 degree, the voltage are said to be balance. Okay, so this implies that VAN plus BBN plus VCN is equals to 0. So once it is balanced, okay, so you know that the magnitude of VAN, okay, is equals to the magnitude of VBN and equals to the magnitude of VCN. So the terms of balanced three-phase voltage, okay, the definition is definitely are equal in magnitude and are out of phase with each other by 120 degree.